Right now, we're going to take your revision for the Cambridge IGCSE physics energy topic and upgrade it from a stressful last-minute scramble into a literal bulletproof scoring system. Seriously, forget all that generic study advice you've heard. In this explainer, we are completely rewiring exactly how you approach energy stores, transfers, conservation, and efficiency, so you can learn to think identically to the person actually grading your exam paper. Okay, I need you to lock in your answer right now. Which of these common mistakes do you think cost students the absolute most marks in energy calculations? Is it A, grabbing the wrong equation, B, leaving out your units, or maybe C, rounding your numbers way too early? I want you to pick an answer right now. Seriously, don't wait. Make a choice, because you might actually be falling into a massive trap that destroys physics grades year after year. Okay, let's dive into this. If you picked B or C, well, you're definitely on the great track, but the truth is actually far more brutal. The true mark killers across the board are missing units, rounding too early, giving those kind of vague explanations, substituting the totally wrong variables into your equations, and this is a big one, writing conclusions that just aren't supported by the data you calculated. These are basically invisible leaks that are sinking your grade even if you perfectly know the physics. And this brings us to a really painful learner mistake, thinking that just memorizing the textbook is enough. Spoiler alert, it's not. Simply reading over your notes is a totally passive strategy, and it completely ignores how Cambridge examiners actually award points. You can memorize literally every single definition for work, power, and efficiency, but if you don't write it down using mark scheme thinking, you walk away with 0 points. Ordinary revision fails because it just doesn't prepare you for the strict rules of the actual exam. So how do we actually fix this? Well, by using a 4-step scoring system that forces you to transition from a passive reader into an examiner. Here's how it works. Step 1, identify the core physics concept. Step 2, pull the exact evidence or data straight from the question. Step 3, apply scientific reasoning to connect those two things. And finally, Step 4, output your answer using strict examiner wording. This framework right here, it's your secret weapon to securing literally every possible mark. Now, in just a moment, I'll show you the exact examiner clue that changes an answer completely and how failing to see it ruins a high-value calculation. But first, we really need to understand the weight of this warning straight from the examiners themselves. They explicitly state that candidates lose marks by failing to use correct terminology or providing unsupported conclusions. Think about that. If you aren't using the framework, you're basically volunteering to hand back your marks, and we definitely don't want that. Now, what's really interesting about this slide is that knowing the physics equations just isn't enough if your data doesn't back up your final statement. Like if you say a motor is highly efficient, but your calculation literally shows a 0.2 efficiency, well, your conclusion is completely invalid. The examiner's clue here is super simple. The numbers you calculate must be the absolute bedrock of the English words you write right next to them. Let's escalate the stakes a bit. Picture this. You're sitting in the exam hall, the clock is ticking down, and you get hit with a high-value, multi-part question about energy stores, efficiency, and power. This is where the pressure really peaks, right? A standard student is just going to panic, plug a bunch of numbers into a calculator, and scribble down a single sentence. Let's look at exactly how a standard student handles this and why it fails so miserably. Here is a classic flawed student answer. Energy is lost, so efficiency is low, 0.4. Guys, this is a total disaster. Lost is a banned word. Energy is never lost, it's conserved. Now, compare that to a top-band response that flawlessly applies our 4-step framework. Thermal energy is dissipated to the surroundings. Efficiency equals useful power out divided by total power in, which equals 0.40. See the difference? It states the concept, uses the correct equation, and applies precise terminology. Let's quickly break down why that top-band answer gets full credit. It secures every single method mark. First off, the correct terminology is used. We say dissipated instead of lost. Second, the equation is clearly stated before any numbers are even touched. Third, the values are substituted correctly. And finally, exam-safe wording is applied. If you follow this checklist, you make it basically impossible for the examiner to deny you your points. All right, time to put you in the hot seat for a spot the error challenge. The kinetic energy is 500. The power transferred is 50. Pause for a second and predict exactly what is wrong with this statement. What critical exam rules are being broken right in front of your eyes? Use the framework we just talked about. What's missing? Did you spot it? So the crucial point is the complete lack of units and context. The correction is simple but absolutely critical. Kinetic energy equals 500 joules and power equals 50 watts. Leaving out joules and watts is the fastest way to instantly forfeit your final answer check. Seriously, a number without a unit in physics is entirely meaningless to an examiner. To stop that from ever happening to you, you've got to build a bulletproof shield for your hard-earned calculation marks. You need to run these final answer practical checks every single time. Are your units present? Are you using the correct significant figures? If it's a graph, are your scales actually accurate? Have you checked for uncertainties? And honestly, most importantly, have you verified the reasonableness of your answer? I mean, if you calculate the power of a standard light bulb to be 3 billion watts, you need to catch that mistake before the examiner does. And this brilliantly illustrates a much larger challenge. Mastering Chapter 4 on forces and energy, getting your efficiency calculations perfect, and nailing your exam wording, that's all fantastic, but it is only a fraction of the overall battle. Energy is really just one piece of a massive puzzle you're expected to solve on exam day. Let's move to and see how this builds, because the reality is we still have thermal effects, motion, and pressure to conquer. This creates a massive, unresolved problem for your revision right now. You have the framework for energy, but how do you apply this mark scheme thinking to the really complex specific heat capacity questions in Chapter 5? Or what about the vector momentum calculations in Chapter 2? Here is the harsh reality check. You only have 7 days left to map out the entire rest of this syllabus. You absolutely cannot afford to spend hours passively reading textbooks anymore. You need a targeted, day-by-day strategy to apply this exact framework to the hardest remaining skills in the 0625 syllabus before time totally runs out. That makes our next explainer an absolute necessity for your survival. So, are you ready to conquer the rest of the syllabus? Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Go ahead and click the link to access your ultimate last 7 days revision map. Do not leave your final grade to chance, guys. Will you take this framework and think like an examiner? Or will you let your hard work just get lost in translation? The choice is entirely yours.